design and the asphalt emulsion formulator all work together to achieve. Right, Rich?
Mhm.
So, okay. Okay, so these are the, when Pat's doing the work, or we're doing work here in the Tulsa lab, this is what we're thinking about. How warm is the weather going to be? How warm's the air going to be? What is the formulation to be? Then the civil engineering aspect of how much asphalt we need in the mix, right? What can we handle it physically in the mix design range? So in terms of temperature, it's going to affect mix time. Cool generally slows down the mix, right, Rich? Right.
And when we talk about temperature, as we said earlier, the temperature of the aggregate, the temperature of the emulsion, the weather temperature, the ambient temperature, surface temperature. However, one that a lot of people miss is the water temperature. The water temperature will have an effect on the mix also. So if you have water that's heated for any reason in your machine, it may accelerate the break time and reduce your mix time.
Yeah, something as simple as a water truck on the job site that's painted black, right? I mean, just,
Yeah.
I mean,
Bad situations where crews working at night and, it was just standard operating procedure for the crew to go get water early in the mornings after they'd shut down and fill up all their tanks so they were ready to go that evening when they came back into work. However, they struggled early evening every night when they'd start up but as soon as they'd go get their first load of water, the problem would go away. And what it was is that water sat in their tank all day in 100-degree temperatures and heated up. And the more heat that it got gained, the faster it made the mix. So temperature is a very important part of the system. And formulation, when we talk about the formulation, that's something that requires good communication between the crew and the emulsion supplier so that you can stay on top of how fast the system is. Is it too fast where you need to slow the formulation down, too fast or too slow to where you need to speed it up? It's important to have that good line of communication. Once again, emulsion versus residue, as I talked about earlier, and I'll stress on this one because, if you are supposed to be putting in 7.8% binder content or solids content, which is say 12% emulsion at a 65% residue, and all of a sudden your residue on your emulsion drops to a 62%, and you're still putting in 12%, there's a pretty good chance that you're out of mix design parameters on the amount of binder needed to glue that aggregate together. So it's very important to remember the residue or binder or asphalt, whatever you want to call it, is the glue. The rest of it is just there for consistency in the mix.
Right. We talk a lot about temperature. We talk about formulation, the asphalt particles. This is where we're back towards pavement design, right? Asphalt cement provides the durability. If you miss that target, you can either make it less durable or it could flush and things like that. So the same rules that govern hot mix govern asphalt emulsion mixes, particularly slurry and micro. So like
kind of the next one is handling the emulsion. This is very important also. It's pretty easy I've seen this numerous times where they're loading the nurse unit or the truck mount with emulsion. They're pumping it into the tank. Then they get the tanks full, so they throw the pump into reverse. And so they close their valve, unhook their hose, and just leave the pump running in reverse. Well, what happens when you do stuff like that, it's sitting there pumping air back into your storage tank. And the more air it pumps in there, the more likely, or it could possibly break the emulsion. It's going to foam it, which would accelerate it breaking and falling apart. So over pumping emulsion, whether it's incorporating air or just circulating emulsion, is very hard on it. There are some emulsions that will handle it better, and some pumps are a lot easier and gentler on the emulsion. However, if you don't have to be pumping it, it's probably better not to be pumping it. and reduce the stress on that emulsion.
When you think about it, if you're stabilizing a foam, if you're putting bubbles in there, the bubbles are actually using up part of the emulsifier to stabilize them. So you're robbing what should provide the mix with that time to get out of the machine with to make bubbles. So again, lots of things to tell you, don't let the emulsion in the storage tank or in the used truck get full of foam. And excessive pumping, everybody that formulates, we run pumping tests on new formulas and things like that. But excessive pumping more than a few minutes at a time can often cause, especially if there's only a little bit left in the truck, can really cause a lot of problems in terms of material depositing on the rotors of the pump or a valve or something like that, or plugging your screen. So avoid pumping when there's no reason to pump it, and pumping it again won't make the problems go away. So avoid that.
That just mix, design, and range.
Yeah.
When it comes to microsurfacing and slurry, work is different than hot AC or chip seal emulsion. Microsurfacing or slurry emulsions work best between 90 degrees Fahrenheit and 130 degrees Fahrenheit. Microsurfacing emulsions and slurry, as we mentioned, when they are too hot, will reduce mix time and laydown time.
And if, this is always good to listen to your actual supplier. They may have a preferred temperature in terms of loading and delivery and use, but again, the intent there is some that remains stable, but isn't so reactive that when it sees that rocks or it's trying to attack it too fast, basically, right, Rich? That's, and a little extra heat will not help you here. It just will accelerate the way that it breaks. So,
hot is not better
yeah.
with microsurfacing or slurry. So,
and that whether that heat comes from storage or hot rock or hot water, chemically it all has the same outcome in terms of the placement. Those of you that remember your basic chemistry, every time you increase temperature 10 degrees, it's going to double in its reaction speed. You're running a chemical reaction in the back of that truck. So you want to avoid doubling the speed of the material if you're already working pretty hard to get it down, right, Rich?
Yeah.
So
okay, weather forecast. Once again, we're back to planning. Weather, it can have a significant effect on mix time, break time, traffic time, even long-term durability. Things to think about when planning is what type of work. If it's cool in the mornings, warm in the afternoon. In the morning, cool mornings, you may want to do, if you have a bunch of approaches or something to work out, that might be a good time to do those, or a lot of hand work. Warm afternoons, if you're out, say you're working on a major arterial street where you have to do the approaches and then you have to do the main lanes. Well, you might want to do the approaches earlier in the morning and do the main lanes in the warmer afternoon, or as the temperatures rise. As we've said, temperature speeds up the mix time. So when you have traffic coming out at you from all directions, you have a little better chance to protect it the faster the system is breaking and curing out. It can have an effect on start time, stop time, because of the amount of time it takes it to cure. Cloudy weather can affect it, slow it down some. Even though it's a chemical break, sunshine still produces heat and will accelerate that break on that system. Rain before or after, it can have a significant effect on the surface temperature that you're applying the material on. So those are things all to take into consideration when it comes to weather and planning and working out a schedule and making the best and using the weather to your advantage.
One aspect of rain, if it's rain right before the job, well, you've carefully designed this mix to work with a certain amount of water, right? If you're running through puddles or the surface is damp, you have excess water, right?
Mm-hmm.
And at the end of the job, if that rain moves in a half hour after the truck goes by, boy, now you're doing a soak test really early, right? And before it has a chance to fully cure out. So generally speaking, avoid rain too close to either the beginning or the end of that job. Just to kind of illustrate that, Rich talked about the effect of clouds and roadway temperature. Even on a nice day, perfect, as Rich as a paving guy looks at, oh, perfect day, 85 degrees Fahrenheit. That road's already 120 degrees, 125 degrees Fahrenheit. So that it's going to make the mix react quickly as it comes in contact with the road, right, Rich? Mm-hmm. So, and if you're ever out there with an IR gun, shoot that road later, especially on a nice new micro or slurry. It's black, it heats up pretty quick again behind once you've gotten the water off the surface of that. So roadway temperature, another important thing to monitor. Some mornings, early, late season, that road may be really cold, even if the air temperature is warmed up a little bit. So.
Okay, here's something that kind of goes along with troubleshooting. As we mentioned earlier, getting retained samples of the emulsion, the aggregate, and doing hand mixes. We've mentioned doing hand mixes a couple different times through this presentation, but here's an example of a hand mix kit. It'll allow you to check the behavior of the on-site materials, determine if it is a variation of materials or process, or possibly just, as I said earlier, a minor machine issue with a partially plugged screen or something to where you're not getting the full flow, and it will essentially make your calibration off a little bit. So
really, all you actually need, portable scales are cheap now. Something to stir with. In this case, these are simple tongue depressors. This is a timer and a temperature indicator, right?
Yeah, that's a rate or temperature gun.
Temperature, yeah. And a little water and measuring cups, and
that entire little kit might cost you $25.
Yeah. So,
but it can save you a lot of time and a lot of headache if you do go down for any reason, to help you to figure out where the problem is really at.
And it saves you running back to a laboratory, which can be a real time saver. So.
Now, one other thing we want to talk about is the equipment, and you can go on past this, and we kind of covered that, but the equipment maintenance. It's important that your machine is calibrated and that you periodically check that calibration. It's important that the monitors, meters, whether flow meters or whatever, work properly on the machine, and that you check wear items, pug paddles, different skirting on conveyor belts and things to make sure they're properly adjusted and not getting worn out. And cleaning is so important, that you keep your equipment clean. Spreader box, the pug mill, if you don't get it clean, you're going to get drags and have ugly surface that's just not pleasing to look at. As far as the calibration, accurate delivery, the monitors and meters, as I said, over time, trends over time, so you can see if the water or pre-wet is going up for no apparent reason other than, it could be temperature, it could be other things, but it's a telltale sign that something's changing. So it's worth looking at. Wear items really can have a lot to do with mix performance and how well the mixer mixes or the spreader box moves the material with the augers. Proper adjustment can have a significant effect on mix placement. And as I said, cleaning, fewer drags, and much more pleasing looking surface.
And again, walking around a machine, knowing what you're looking at, even asking the operator what things are doing is a good thing. I was on one job where, man, the mix just was sloppy wet. It wouldn't cure, and we monitored the water, we turned it down, and it just stayed that way. And finally, we just had the operator turn the machine on, found out one of the electronic valves had failed, and the minute the machine went on, just dumped water into the mix, whether you wanted it or not. It was in the additive system. So sometimes just, and we had proven to ourselves using a field kit that the mix should work. So we were really scratching our head, but it was a single valve on a single dilution line for the additive that caused that problem. And without the field kit, we would have still been out there trying to figure out what was going on. So.
Okay, there's just a little short video. As I said, on the proper adjustment, I don't know how many times I've been out of the job, even when it was my own job. First job out, I put in new augers all ready to go, and I had the augers flip-flopped and to where they were turning in reverse and not moving the material efficiently. So it's important that the rotation of the augers is correct and that the distance off the road surface, you want to reduce that as much as possible to reduce dead areas. The tighter you can get those augers to the ground and to that back strike off, the smaller that dead area and less buildup you may get.
So again, you may want to just walk through, Rich, how that auger's pulling that material through the box.
Well, you want the rotation of the augers so the bottom of the auger is coming back towards the back strike off. If it's turning the other direction and the spirals, or even if the spirals are trying to pull the material out, it's throwing the material forward. And a lot of times it doesn't move it efficiently. And the other thing it does, it'll throw it forward and it kind of segregates the mix. So it's important that your augers are turning in a rotation to where they're using the strike offs to hold the material against them.
All right, thanks.
So troubleshooting basic guide, be able to describe what is not working. We had in more detail on this, so often when we do get asked for help on a problem, we'll ask, they'll just say it's not working. Well, try to be a little more specific on what's not working. Is it breaking in the box? Is it too slow? Is it too fast? Is it raveling? Is it flushing? So be specific when you're describing what is not working. Determine what may be the cause of the problem. And a lot of times you have to be careful there to where you want to keep looking sometimes, because you may find a symptom of the problem. And by fixing that, you really haven't fixed the problem. So it's important to try and go back as far as possible to fix the actual problem when possible. And as I says, fix the problem at the source. And then ask yourself, when was it working? What changed? Where? Was it a new road, new stockpile? What to do next? And seek help if necessary. And as we said earlier, when should troubleshooting begin? Don't wait till the wheels fall off. You can troubleshoot and have a lot of things that can be telltale signs to where you'll see symptoms of problems that are brewing, and you can usually head them off before they become a real problem.
And that is it. If anybody has any questions, either go in through the chat or get a hold of Rich or myself, and we'd be glad to provide the answers as best we can.
Oh, I'm sorry, I didn't mean to interrupt him. We do have a couple questions.
Okay.
One from Alexander Garcia Santos.
Hold on, I'm going to need to, can you put your earphone on? Can you hear?
Oh, no problem.
Hold on, we're going to need to get Rich on this.
Okay.
Go ahead. Sorry, Kate, go ahead, please.
So we have one from Alexander Garcia Santos. He asked this at the beginning, so it might be for Pat. Where a residual asphalt sample is sampled to determine the asphalt cement content?
Well, that could be for Pat or us.
Okay.
Basically, he's talking about doing an ignition oven or an extraction to determine the amount of binder in that mix. You'd want to most likely contact whoever your emulsion supplier is, and they may have the equipment there to do it, or they'll send it to one of the other labs like Road Science or Ingevity, and we can test it for them.
Right. And oftentimes it can be set up as part of the job spec that want to clarify on the question. Is it the asphalt cement content of the asphalt emulsion or the asphalt content cement content of the mix you were asking about?
They might have re-asked that, and it might be, I'm not sure because I don't know the label. Here's the second question they asked, which might clarify. They asked where in production where the residual asphalt sample is taken to determine the asphalt cement content. I'm not sure if that.
Oh, the asphalt emulsion. Normally that's at the completion of a batch run in an asphalt emulsion plant. The tank is mixed and then sampled, and quality control in terms of viscosity, asphalt content, any residual properties are determined at the end of a batch production run. So conversely, if it's in the field, Rich, right, you have to sample it basically behind the pug mill, right?
Yeah.
And this is for the mix rather than the asphalt emulsion. And there's some specific techniques that Rich and really a couple NCAD have worked out for obtaining a good representative sample asphalt content off the mix, correct? So,
Yes, we found that when you do pull a sample, it's since it is in a liquid form, semi-liquid form, and the material is designed for emulsion to drain down to help adhere it to the existing surface. So it's important, whatever the container is, you catch it in, usually a shallow pan, like a 2-inch deep cake pan, that you mix that material until it breaks or thickens up to where it's not fluid any longer. That makes it much easier to quarter and get representative samples.
All right. And we have another one from Jessica Ramones. It says, when the PSD changes according to the one we designed for and crew are using the same emulsion amount, how do we know how much the bitumen film index gets affected?
right. In that case, the parameters of the mix design define the asphalt content. And during the mix design, the minimum is defined and the range is defined. So within the mix design, that is allowed for. We do essentially moisture resistance and durability tests during the mix design that define that asphalt content. And rather than I believe the question was really about film thickness and the changes that would entail if the asphalt content changed, right? Maybe if the person asking that question could clarify that.
She does have a follow-up question, says, complementing my question about the bitumen film index, there is a tolerance on BFI that we can use the same emulsion amount when PSD changes. How correlative is this BFI to the amount of residue that the mix should have?
I think we'd have to go and probably want to get with this person and walk through what the question is a little clearer. So what do you think, Rich?
Yeah.
We want to see the concerns on a table. So
They're more than welcome to contact any of us, and we'd be more than happy to help them in any way we can.
And for the attendees, that is possible. You may search for people under the People tab at the beginning and look for the speakers. And if you'd like to send them a message, you can. Is there anything else you guys would like to go over?
we appreciate the opportunity. Appreciate everyone that spent the time with us this afternoon, and hopefully it was useful to them. And hope to see you in the field sometime. So.
Yeah, absolutely. Thank everyone for attending today, and hope it was informative for you. So thanks everyone for stopping by and listening.
I'd like to thank Pat, Tim, and Richard, and I appreciate everyone for joining. This concludes today's session. We wanted to thank you all for attending the 2021 Virtual Slurry Systems Workshop. Please leave us feedback if you'd like, and please check your email for a survey that will be sent out tomorrow, January 22nd. Lastly, please join us for our last networking hour, which starts at 3:45 p.m. Central Time. Thank you very much.
Thank you all.
Great job.
Thank you,
Tim.
Kate.
Great
All
job.
right.
Very welcome.
Bye-bye.